practiced with RapidMiner on regression already, maybe a couple times. Let's see how it works with classification techniques. All right, so I've taken our last process and I've resaved it as a classification example, and I've kept the initial data retrieval and initial prep subprocess. I'm bringing in the bike buyers data set now. And then I have updated the set role so that I am bringing my purchased bike in as my label value, and then ID, which is basically an ID field. I'm keeping it as an ID role. Basically what that means is that the model, the algorithm won't use it to try and predict the value, but it will keep it in the data set and pass it forward so we still have it available. Okay, so now let's go back and we will go to our next sub-process where we did the algorithm-specific data prep. We'll call this data prep for decision tree. And we'll call it data prep tree. All right, so I'll give it a note. All right, so we've got the split validation that we've had before, and what I'll do in the data prep for the tree is I'll select the attributes. Now with the decision tree, I don't need all of my attributes to be numeric. I can use the categorical attributes. So what I've done is I've said I want to include attributes, a subset, and then I've selected which ones I want. So I've got age, cars, and children, which are numeric, the income, which is numeric. I'm keeping the ID, which is now an ID attribute, commute distance, education, gender, homeowner, marital status, occupation, and region, I am keeping as categorical. So I'm leaving the numeric versions of those behind. And then I'll bring in purchased bike so that I have my label value. Okay, so now I apply it, and I'm going to multiply because I want to keep the entire data set later on for scoring. All right, so now I've got my output going into split validation. And if we remember from looking at that before, we've got a vector. Well, I've got an old regression technique that I was looking at in there. Let's bring in our decision tree. All right, so decision tree is right here. I'll bring in my training data. I will connect my model to the first output port on the wall, and then I want my weights as well. I want to see what my weights are. So that will continue through to the output. Okay, so now apply model. And now I've got a regression performance operator here. Let's get rid of that. I don't want to evaluate this as a regression model. I'm now going to evaluate it as a classification model. So let me get rid of my search, and I'll go into validation, performance, predictive, and then this is a binomial. I'm going to either purchase the bike, the customer will either purchase the bike or not. So this is binomial classification. I'll bring that particular performance metric in. So I've got my labeled data that I can then bring in. I've got my performance data. And then I want to bring my weights through. And I'll bring them to that one, okay? All right, so I've got my apply model. Oh, I need my unlabeled data to be able to apply the model. Check my performance with the labeled data. All right, so let's see what I have coming out of my split validation now. I'll go ahead and delete everything. All right, so I've got my model, and I'll go ahead and send that down just like I did before. I've got this data. Let's see, I don't need to see the training data, but I would like to see my model performance. So let's go ahead and look at this. We'll run that. Okay, so I now have attribute weights that I've generated for each of my attributes. I've got my performance vector. So look, I'm doing performance based on accuracy. And because this is a classification technique, I now have my confusion matrix. Okay. Now, I made a mistake. I would like to see more of my performance metrics. My main criteria, let's say we want it to be accuracy for now. Ideally, if I don't know what I'm going to do, and we'll get into this a little bit later, I would go with AUC as my main criterion. But I'm going to go ahead and select all of these other criteria just so I have them available. In many cases, if we know what our positive case is, we may choose a specific metric. If we're not sure what our positive case or what an expected distribution is, things like that, AUC can be a good metric to work with, or the F measure can be a good measure to work with. We'll get into those as we continue discussing modeling and performance evaluation. All right, so at that point, I can go back to my main process window, and I run this, and it's a pretty fast decision tree. I don't have a ton of data in my bike buyers data set. I can see my attribute weights and sort them based on most important attribute, income, then age, home ownership, so on down the line. I can look at my performance, and I've got my whole list of performance metrics here that I can see. And you can also see I have a confusion matrix that shows me my actual predictions, whether I was accurate. So this is a true negative. Here I've got my true positives, my false positives, and my false negatives. All right. AUC, you see, displays as a chart. I've got an AUC of 6.657 right now. Okay. I've got an F measure of 70.04. F measure might be the best analog to R squared as far as classification techniques go. All right. So that gives, and then I can see on the results, I can see, let's see, where's my example? So, oh, here's the actual decision tree itself. So you can see as I zoom in and zoom out, I'm going to go ahead and look at the tight version of the tree. All right, so there's my decision tree, and I can zoom in and see all the details. All right. And then this data set here where I applied the model to the population, I can see both the actual value and my predicted value. And then the model's basically its calculation of its confidence on whether it should have been a yes or no. So here you can see it was 0.694, 69.4% confident it should be a yes. Now, the prediction was wrong in this case. Same thing here, yes, yes. Predicted no, 667, correct. And all the way down here, we have the confidence for no, 0.938, 93.8%, and it was correct. So here we've got the actual class value and the predicted class value, plus the confidence that it would have been either one, along with all of our other original data. And you can see the ID shows up as a blue feature, which tells us it's still available. I can look things up by ID number, which might be useful, but it's not used in any of the calculations. All right. So at this point, I could then bring in a different algorithm. Let's say I wanted to try and do a modeling, and let's do it with, we'll call it predictive. We'll do logistic regression. So I'll bring in logistic regression. And I'll connect it up with the weights just like I did before. I'll go ahead and leave the defaults now. Apply the model, check performance just like I did before with the F measure. All right, so let's go back up to the main process, run it again, and see what our logistic regression gives us. All right, now you can see Regression split all of our categoricals for us automatically and put them into weights. I've got my performance measures as before. My AUC is 0.735. That's a little bit better than what we had with the decision tree. I've got an F measure of 0.6486. Now, I can't remember how that compares with what we had before, but of course, if I were keeping this in my table, I would know. I could see my logistic regression model, which looks a lot like a regression equation that you would see for a regression, but instead of predicting a numeric value, we're predicting this is basically a delineation line where everything that goes on one side is predicted one way, everything that goes on the other side is predicted the other way. Now let's see what my example set looks like. Pretty much the same as before. I've got my predicted value. I've got the actual value of purchase bike, and then my confidence for each potential value of that prediction. So here the confidences are a little bit different, but still on the predicted yes side for this first ID, and then so on down the line. All right, so we would be able to use that to see how well we're doing. If I just wanted to look at the performance, I can look at my accuracy and see my accuracy is 0.675. All right. My error rate, therefore, would be 0.325, and so on down the line to my AUC. You can see I also have an optimistic version of the AUC, so that's also 0.735. The pessimistic 0.735. This is a pretty small data set, so you're typically not going to see a ton of variation like you might see for a larger data set there. All right, so that is binomial classification. Now you can classify binomial or polynomial. Let's see how polynomial might work. So to do this, I'm going to bring in a different data set. I'm going to bring in, instead of bike buyers, I'm going to bring in the lending club. We'll just bring in the small one, lending club small. I'll bring that in. And if we look at lending club small, we can see the thing we are interested in is loan status. What do we predict the loan status to be in the future? Current, fully paid, charged off, late in the grace period, or late 16 to 30 days, or late 31 to 120 days. All right, so I go back and I'm going to set my role, in this case, to loan status, the categorical version. Okay, so I'll set loan status to my label. I'll come back up here, and now I'll say data prep. Oh, we'll do a decision tree again. But I have a different set of attributes now, so I need to select my attributes. So I'll bring in another select attributes. And I will include a subset. I will select pretty much everything. except for the numeric versions of categorical attributes. And just reviewing the data again, loan status, loan amount, issue date. All right, so I can use all of these. Okay, so we have selected our attributes. We can apply that, go back up to our main process. Now, we've got our split validation here. So we'll open that up and use logistic regression. Let's make a decision tree here. So I'm going to go back to a decision tree. So we'll open up modeling, go into predictive trees, and we'll do our decision tree. I'll bring the data in. I'll send the model out. I'll send my weightings out. And then we'll apply the model, just like we have before. And now for performance, I have a binomial or binominal classification operator in here. I need to go and change that now because I have 6 potential outcomes that I might predict. So for validation, I'll go to performance, predictive, and binominal classification, I'm going to bring in the generic classification. So that's going to work better when we have multiple classes, more than 2 basically. All right. So I'll bring my performance in there. And I believe that might be all I need. I've got my weightings, I've got the model, I've got my performance. So now I come back up and coming out, I've got those 3 things. Boy, that split validation is getting big. I need to refresh that at some point. Get rid of those extra output ports. Okay, and then we're applying the model to the population just like we have before. All right, let's run it and see how it goes. All right, so we have familiar output here. I've got each feature in the decision tree along with its weighting. So I could see the total number of the total amount of received late fees is my highest weighted item in my prediction. Total received principal is next highest. The loan amount is a good predictor. And here I can see my actual decision tree itself. I'll go to the tight tree. And you can see it's not really a humongous tree for the number of features that we had. So go back to those weights and you can see only a handful of them really counted for our model. Let's go to the performance vector. And now you can see I've got a confusion matrix that is 6 by 6. All right, so that is a difference from what we've had. I've got a 78.65% accuracy on my guesses here, mostly on fully paid or current. Not so okay on charged off, but certainly plenty missed in these areas as well. I can also see my example set when I apply the model to the population. Here's my predicted or my actual loan status, my predicted loan status, and my confidence for each of the potential outcomes. Fully paid, current, and so forth. All right. So with fully paid being the 0.75, and you can see in many cases the confidence for the selected one is actually a majority. I wonder if there are any where we don't have that as it's possible, I think, that we could have some where that isn't the case, but I don't see any just glancing at this. That would be an interesting exercise. All right, now I did what I've done before, and I forgot to select my additional performance metrics, so I'm going to go ahead and do those. So if I focus on accuracy as my performance metric. Let's run that one more time, and we will see all those performance metrics. Now everything else should be the same, so I'll look at my performance vector, and you can see I've got my error rate accuracy up to 78.65, error rate 21.35, and then all these other various measures, recall, precision, and so on down the list. I can see them all at once by looking at the description, but I get a lot of details with that, so if I'm focused more on one, I can use the measures I see over here. All right, so multiclass, classification, confusion matrix 6x6 in this case. So that gives you an idea of how to work with the classification algorithms and how to evaluate them when you have a binomial classification. You've got some additional measures. The F1 value is an important one, as is the AUC, which is oftentimes the first measure you look at for a classification, a binomial classification technique. All right, so there we have it. And let's go ahead and call it quits for this video and see what we'd like to do next.